So I had a bit of an existential crisis this morning in a coffee shop. I was looking around, and every single person, me included, was just hunched over, staring into this little rectangle of glass.
The modern condition.
We hold them for hours a day. We panic if we lose them. But I realized if you handed me a screwdriver and said, open this up, explain how it works, I'd have no idea. None.
You and 99% of everyone else. It's the most important tool we have. But for most people, it's a complete black box. You tap the glass, magic happens.
Exactly. And that bothers me. So that's what we're fixing today. We are cracking open that black box. And we're not just, reading a user manual.
No, not just.
We've got sources based on technical training modules for the CompTIA A+ certification.
Right. This is the stuff they teach the people who fix your laptop or manage 1,000 iPhones for a company. This is the mechanic's handbook.
So our mission today is to go from just being a user to being a power user. We're going to unpack everything from that weird little red button on some keyboards to the invisible handshake that happens when you pay for a latte.
It's all about understanding the convergence. You've got radio engineering, material science, software security. It all just smashes together right there in your pocket.
Okay, so let's start with the hardware, the stuff we can actually touch. I was scanning the notes on input devices, and one thing just jumped out at me because it feels like a fossil. The nub.
Ah, yes, the track points.
Is that the official name? I feel like everyone I know just calls it the red dot or the eraser head.
The generic term's a pointing stick, but TrackPoint is the IBM and now Lenovo brand. You see them on ThinkPads mostly.
But my question is, why does this still exist? I mean, we have these massive, amazing glass trackpads now, touchscreens. Why is there still a rubber nub between the G, H, and B keys?
It's actually all about efficiency. For a certain type of user...
Like a coder.
Exactly. A touch typist. Think about it. To use the touchpad, you have to physically lift your hand off the home row, move it, swipe, then find your way back to the keys.
That's a micro interruption, I guess.
It is. The nub uses a strain gauge. You don't actually move it, you just apply pressure. The harder you push, the faster the cursor goes. Your hands never leave the keyboard.
Oh, okay. So you never have to do that thing where you run out of trackpad and have to pick up your finger and swipe again?
You never row with a pointing stick. It saves a huge amount of hand movement over a full day of work.
That actually makes sense. It's a specialized tool, not just a relic. The sources also mentioned the stylus, which surprised me. I thought we all agreed fingers were better years ago.
For navigating, sure. But the material here makes a key distinction. We're not talking about that old, dumb plastic stick from a Palm Pilot.
Right.
We're talking about active digitizers.
Like on an iPad Pro or a Surface.
Exactly. They're active, they transmit pressure data, tilt, they have buttons, they bridge that gap between handwriting and digital input that a finger just can't. You can't draw a schematic with your fingertip.
Speaking of bridging gaps, let's talk about the desk setup. I think a lot of people, myself included, get confused here. The training modules are really sharp on the difference between a port replicator and a docking station.
Oh, this is a huge pet peeve in IT. People use them interchangeably, but they are not the same thing at all.
Okay, so help me out. If I buy one of those little dongles on Amazon with a few USB ports, what is that?
That is almost certainly a port replicator. Think of it like a glorified extension cord for your ports.
Right.
You plug it in and it just passes the signals through. It's for convenience. You don't have to plug in 5 different cables every morning.
And a docking station.
A dock is transformative. A true dock often uses a much higher bandwidth connection, maybe a proprietary one.
Yep.
It doesn't just pass signals through. It can add hardware capabilities the laptop doesn't even have. Power delivery, driving multiple high-res monitors, sometimes even external graphics. A replicator makes connecting easier. A dock makes the computer better.
That is a crucial distinction. It explains why one box is $50 and the other is $300.
Exactly. One is just wires. The other has a brain inside.
So let's stick with the wires for a second. The ports on the side of the laptop, the notes call it an alphabet soup. RJ45, HDMI, but the real chaos seems to be USB.
Ah, the universal serial bus, which is becoming less and less universal, ironically.
We got USB-C, micro B, mini B, but USB-C is the one taking over, right? Everything have that little oval plug?
Physically, yes. The connector itself is winning. But here's the power user insight that catches everyone out. Just because 2 cables have a USB-C plug doesn't mean they do the same thing.
Wait, what? A cable isn't just a cable?
Not anymore. The connector is just the shape. The protocol, the data inside that cable can be totally different. One USB-C cable might just be for charging. Another might carry slow data. and another could be a high-speed Thunderbolt cable that can carry video.
So that's why my cheap charging cable won't connect my monitor.
That's exactly why. It's physically missing the wires inside for the video protocol.
Yeah.
You have to check the little logo on the cable, not just the shape of the plug.
I feel so vindicated for my box of useless cables. Okay, let's cut the cord. Part 2. The wireless ecosystem. The notes have a great line. Strip away the glass, and your phone is just a collection of radios.
That's all it is. A tiny broadcast station constantly screaming into the void, hoping something screams back.
And the biggest radio is cellular. We throw around terms like 3G, 4G, 5G, but the CompTIA stats show the leap between them it's just insane.
It's a logarithmic jump. Look at the raw data. 3G was the breakthrough. It got us basic web pages. It topped out at, what, maybe 7 megabits per second?
Which feels like dialing up now.
It does. Then 4G and LTE came along, and that jumped us to a theoretical 300 megabits.
And that changed everything.
It changed human behavior. That's when you could stream YouTube on a bus. The whole app economy exploded because the pipe was finally big enough.
And now with 5G, the notes are saying speeds up to 10 gigabits.
Theoretical max, yes. That's faster than most people's home internet. But for the power user, the speed isn't the real story. It's the latency.
The lag time.
Exactly, the reaction time. 5G responds almost instantly. That's what enables things like self-driving cars talking to each other. It's not just a faster download, it's a faster reflex.
Okay, but here's something that always bugged me. With all these phones, all these signals flying around a city, how does a cell tower know which one is mine?
That's the whole job of the SIM card, the subscriber identity module.
It's basically your phone's ID card.
It's a tiny smart card, yeah. It holds your unique number, your MSI, that tells the network, hey, I am this specific user, and here are the secret keys to prove it. Without that, your phone is just anonymous noise.
And they just keep getting smaller. Standard, micro, now nano.
Right. The chip itself is the same size, but they just keep trimming the plastic around it to save every last millimeter inside the phone.
Speaking of using that connection, let's clarify 2 terms I always mix up. Tethering and hotspots.
Okay. The end result feels the same. Your laptop gets internet, but how it works is different.
How so?
Tethering is a one-to-one connection. You plug your phone into your laptop with a USB cable, one device talking to one other device.
Okay.
A mobile hotspot turns your phone into an actual router. It broadcasts a network name, an SSID, and multiple devices can connect to it. Your laptop, your friend's tablet, whatever.
So a hotspot is way more work for the phone.
Oh, significantly. It's managing traffic, doing network address translation, broadcasting a signal. It absolutely destroys your battery.
Which brings us to the kill switch, airplane mode. I always thought that was just a polite software thing.
No, it's a hardware command. When you flip that switch, the OS physically cuts power to the radio transmitters.
All of them.
All of them. Cellular, Wi-Fi, Bluetooth, GPS, NFC, they all go dark.
Wait, why GPS? GPS is just listening to satellites, isn't it?
It is, but on many chipsets, the GPS radio is on the same physical piece of silicon as the cellular radio. So to guarantee one is off, you have to kill the whole chip. Plus, the goal is zero potential interference with the plane.
You mentioned NFC in there. Near field communication. This is our part 3. The invisible handshake. The tech that makes me feel like a wizard paying for coffee.
It's the closest thing to magic we have, but it's just physics. Inductive coupling.
Inductive coupling. Okay, break that down for me.
Think about your tap-to-pay credit card. It has an NFC chip, but it has no battery, right?
Right.
So how does it have power to send a signal?
I have never once thought about that.
The payment terminal itself emits a tiny magnetic field. When you bring your card or your phone close enough, we're talking a few centimeters, that field induces an electric current in the card's antenna.
It powers it up through the air.
Just for a fraction of a second, just long enough for the chip to wake up, shout its security code, and go back to sleep.
That's amazing. And that closeness is its security feature.
It's the best security feature. You can't skim it from across the room.
The notes say we also use it to bootstrap Bluetooth.
Yeah, it's a matchmaker.
For when I tap my phone to a speaker to pair it.
Exactly. Bluetooth pairing can be a pain, searching for devices, entering codes. NFC just handles the introduction. You tap, and the NFC says, "Hi, speaker. This is my phone's Bluetooth address. You two talk." Then Bluetooth takes over.
And Bluetooth itself, the sources call it a PAN.
A personal area network.
Sounds cozy.
It's a good way to think about it. The internet is a wide area network. Your home Wi-Fi is a local area network. Bluetooth is for the bubble around your body. Your watch, your headphones, your car.
Let's stick with networks and talk Wi-Fi. There was a detail in the hardware diagrams that blew my mind. I always just assumed the Wi-Fi antenna was down in the base of the laptop.
Most people do, but if you put it down there, it's right next to the processor, the storage, the battery.
A ton of electronic noise.
A ton of interference. Plus, your hands would be blocking the signal when you type.
So where is it?
It's in your screen.
Yeah.
That plastic or metal frame around the display. The bezel.
You're kidding me.
Nope. The antenna wires run from the main board up through the hinge and are taped around the inside of the screen frame.
So when I open my laptop, I'm literally raising the antenna.
You are deploying the mast. It gets the antenna up high, away from the noise, for the best possible reception. It's brilliant, but a nightmare to repair.
I bet. Now, what about when I'm inside, away from any windows, and my phone still knows exactly where I am in a shopping mall? How does that work without GPS?
It cheats. Your phone is constantly scanning for Wi-Fi networks and Bluetooth beacons.
Even if I'm not connected to them?
It doesn't need to connect. It just needs to see their names. Google and Apple have these huge crowdsourced maps of where every Wi-Fi router in the world is physically located.
So it sees the Starboy Wi-Fi and the Gap Wi-Fi.
And based on the signal strength of each, it triangulates your position. The routers act like indoor satellites.
That is incredibly clever and also slightly creepy, which is a perfect lead-in to part 5. The brains, the OS and security.
The eternal battle. iOS versus Android.
The training material calls iOS a walled garden.
Which is a perfect description. It's a philosophy of total control. Apple has to approve every single app, every update. The upside is very high security and consistency.
But the downside is I can only do what Apple says I can do.
Correct. Android is the open market. You have the Google Play Store, which is curated, but you can also sideload.
That's when you just download an app from a website, right? An APK file.
Exactly. You have total freedom, but you're also the head of your own security. If you download a malicious file, you just invited a virus into your house.
But no matter which OS you use, they both have this concept of the sandbox.
This is one of the most important security ideas in modern computing. Every app lives in its own separate digital prison cell.
So the flashlight app can't read my emails.
It can't see your contacts, it can't see your photos, it can't see the data in your banking app. They're walled off from each other.
Unless I give it permission.
Exactly. When you see that pop up that says, allow access to photos, that's you, the warden, punching a specific temporary hole in that prison wall.
Okay, now let's talk about work phones. The overlords. MDM and EMM.
The corporate control stack, yes.
MDM is mobile device management. This lets my company basically own my phone, right?
If you enroll it, yes. They can enforce policies like requiring a PIN. They can disable the camera. And the big one, they can remotely wipe it.
If I leave it in a cab.
They push a button, and the next time it connects to the internet, it erases itself completely.
But what if it's my personal phone? The sources mention MM.
Right. Mobile application management. This is the newer, smarter way. Instead of managing the whole device, it just manages the work apps.
How does that work?
It creates a secure container on your phone. Just for Outlook, Teams, your work stuff. They can wipe that container if you leave the company, but they can't touch your personal photos or apps.
They can't wipe my camera roll.
Exactly. And it can even stop you from copying text from a work email and pasting it into a personal app. The container itself is locked down.
It's a phone within a phone. Okay, final part. Under the hood, let's say I want to fix one of these things. The training modules get a bit scary here.
It's a very delicate operation, fragile.
They talk about ribbon cables.
Paper-thin, flexible cables. You pull a little too hard when opening the case, and you just hear a little snap. And that's it. It's broken. You can't solder that back together.
And you can't just use a normal screwdriver. You need a spudger.
I love that word.
What even is it?
It's a little prying tool, but it's made of plastic or nylon. It's non-conductive. You use it to pop open connectors, especially the battery connector, without causing a short.
Ah, because of static electricity. ESD.
Electrostatic discharge. That tiny little spark from your finger that you can't even feel is like a bolt of lightning to a microchip. It can fry a logic board instantly.
And finally, the most dangerous part, the battery itself. The notes distinguish between Li-ion and LiPo.
The practical difference is mostly the shape. Li-ion, or lithium-ion, is usually in a hard metal case, like a cylinder or a brick.
But you can't fit a brick in an iPhone.
Exactly. So they use LiPo, lithium polymer. It comes in a soft, flexible foil pouch. You can make it super thin, shape it however you want. It's what allowed for the whole Ultrabook and modern smartphone design.
But if you puncture that foil pouch,
You get fire. Thermal runaway, it's a very volatile chemical reaction.
So leave the repairs to the pros with the Spudgers.
Generally, yeah.
That's a good idea.
We have covered so much ground, from the little rubber nub to corporate containers. What's the big takeaway for you from all this?
For me, it's that we need to stop thinking of these things as appliances, like a toaster. They're not. They are deeply complex, managed, networked computers. And when you understand that the bezel is the antenna, or what airplane mode actually does, you can start to troubleshoot and use them more effectively, more securely. It definitely changes how I think about that owner account. We talked about how app stores dictate what we can install, how companies can wipe our data. It leaves me with this one last question. If Apple or Google controls the software and my company can control the data, do I really own this phone, or am I just leasing a terminal from them?
In a world of walled gardens and cloud management, ownership is becoming a very, very fuzzy concept. You own the glass and metal for sure. The rest is debatable.
Something to think about the next time you unlock your life with your face. Thanks for diving in.
Pleasure as always.
We'll catch you on the next deep dive.